in this problem, we're going to take a quick look at how to calculate standard deviation. I picked this set of 6 numbers, and we're going to solve on them. First, we need to determine what the mean is. That is to say, the average. What most people call the average. Here is represented by the Greek letter mu. Looks kind of like a little U. Okay, to find that, we want to add these all up and divide by how many we have. So we add those all up, we get 20. And there's 6 of them there. 1, 2, 3, 4, 5, 6. So 20 divided by 6 is, that's 10 over 3. That's 3.333. Close enough. Okay, that is our mean. That is mu. Okay, now we're going to take each number, subtract it from the mean, and square it. Okay, so that means, remember, just solve a little bit at a time. We don't solve the whole thing all at once. That would be hard, unless you're a computer. Okay, so first I'm going to have 1 minus 3.333 squared plus 3 minus 3.333 squared plus, we just continue doing this. And we're going to get numbers for each of these. We're going to have to add up a bunch of numbers, and that's okay. I'm just going to put dot, 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 so I have to do it on each one. Okay, let's take a look at the first one. Pull out open my little phone calculator, which I find so handy. 1 and 0.333. If I subtract those two, I get 2.333. If I square that, I get 5.444. Okay, pretty reasonable. Let's do it to the next one. 3 minus 3.3333. Okay. That gives us 0.111. 5 minus 0.333. Okay, let's take a minute and do that. That gives us 2.777. And we'll want to continue to do it for each of these. So that means there's 3 more. So we're going to have 5.44 plus 0.111 plus 2.777 plus 0.111, because our next one's a 3. The next number over here is 3. So we'll have another 0.111. 6. 6 and 3.333 is going to give us 2.666 squared gives us 7.11. No, we don't need that extra one for now. We'll just leave that off. And of course, the whole next we're going to have 2 minus 3.111 minus 3.3333. And that's going to give us 1.777. Okay, now we just need to add these numbers up and see what we get. We're going to get I get 17.333. Okay, so that's what we get when we add those all up is... Now, why am I adding them all up? Maybe I should explain that. You see this little kind of an E-looking symbol. Let me outline it in red. This little symbol right here. This just means we take everything that is over here, all this, and we add it up. It's a big add sign. It's a mega add sign. It's an add sign on steroids. It really is. That's just what it means. It means sum. It's Greek letter sigma. Okay, we don't use Greek letters too much in a lot of places anymore, but back when the Greek letters were the thing, that's when they came up with that. Okay, so we now know what sigma of x minus mu squared is. That's 17.33, which means we now have 1 over n times 17.333. What's n? N is how many things numbers are in our sample. Okay, so we have 6 numbers in our sample, so that's 17 divided by 6. Okay, divided by 6 gives us 2.888. So divided by 6 gives us 2.888. Okay. Now, so the last thing we have. Okay, by the way, this number, in case you're curious, is called the variance. Now we take the square root of that, because now we're down to being nothing but the square root left. The square root of that will be our standard deviation. Okay, so let's plug that number into our calculators again. What do we get? I get, I think I should have gotten a number a little bit larger. Okay, I rounded off some things here. That may have been a problem. Okay, but the number I have here is 1.69967. Yeah, I don't trust it out that far. I trust it out. I've only used 3 decimal places. I don't trust it out any further than that. So let me. Okay. Now the calculation I did previously give me a slightly higher number, which tells me that I got sloppy in my arithmetic somewhere. This happens. It happens to the best of us. So if you may see a small arithmetic error in here, correct it yourself. Put it in the comments if you like. But the procedure here, the procedure is what's most important. If you get the procedure down, then you're in good shape. And then, yeah, you may have mistakes, but as long as you got the procedure down, that's like, having a ninja having a trip over his shoelaces. You know what? Yeah, he may trip, but he still knows what he's doing. Okay, guys, keep working hard. You can do this. Okay, guys, in case you're curious, little addendum here. I figured out why I got the slightly different numbers. There are 2 formulas, actually, 2 formulas for finding standard deviation. They are just a tiny bit different. You'll have like a little +1 right here, or -1, in certain cases. Now, when you have big numbers, and most of the time you're doing these on lots and lots and lots of numbers, hundreds or thousands of numbers, in that case, that little +1 does not make a difference. The formula I was using didn't happen to use that. Okay, now we use these in different circumstances. For low-level students, do not stress about that. Doesn't make a darn bit of difference for you guys. And if you're doing more numbers, if you're doing a large number of numbers, like 100 numbers, won't make a bit of difference. If you're doing 1,000 numbers, make a tiny, minuscule difference. But when you're doing a small number of numbers, then it does make a difference. So watch out for that. Make sure you're using the one your instructor wants.